Welcome. Okay, I'll start now, and then we'll see if some more might be coming on. And Julia from Albion too. Great, super. So welcome everybody to this first Fable webinar in English. And we see that there are people from all around the world that are joining, which is really great. I've been looking forward to this. So Jakob and I will take you through an introduction of Fable so that you can get started with using Fable in the schools that you're in or in the specific sectors that you're in. I'm sure you have loads of different backgrounds. So some of the things I say might sort of be more perfect suited to you than others will. But please feel free to ask any questions in the chat. Jakob, he will take care of it. It says as if it's in writing, but it isn't. We've switched positions, so I can't both write and present to you. So I'm not a magician, but it's Jakob. He will support you. So please interrupt me at any point needed, because I haven't planned with any coffee breaks. So if there's anything specific that you want to know about, you can just ask in the chat. I have, of course, two specific goals with this presentation. One is that you feel comfortable about using Fable, that you get an idea of an onboarding of how you can start using Fable. And the other goal is, of course, that you know how to put it into your lessons or subjects from us planning for next week or even for tomorrow if we were in that situation of being able to be in the classrooms. So, but towards that, I also have a small alternative for you that might make you happy. We'll see.
There's just a question that regards, are we recording this webinar?
Yes.
So I was just maybe thinking that you should say it out loud.
Yes, we will be recording the webinar. So as soon as the webinar is over, at some point you'll then receive an email where you get the full webinar recorded, and we can also share the slides with you. So I will connect with you so that you get them in hand if needed.
I think you will get the email tomorrow, actually. I think
it's automated. So
yes.
Great. And what I'll do now is I'll share the screen with you, and then you can see the slideshow that I will be giving you. I'll be switching a bit back and forth because it's also important that you get an idea of Fable in use so that you see how it works. And also we'll be looking at Blockly. So there'll be some switch between some of the screens, so bear with me if you just have to wait for a minute or two while I do that. So I'll start sharing the screen with you now. And then you should be able to see it in a second from now in a presenting mode, hopefully. And we just have to get back to some of the first slides. I was already, there we go. Do you see my presenting mode, the slides now, Jakob?
Yes.
Perfect. So a short introduction to who we are, I'll give you in a second from now, and then I'll show you some hands-on activities with Fable and create loads of whys, why it is important and why it's necessary for us to work with an educational robot now and in the future in schools. And then I'll just give you a small view and some of the lesson plans. I've put in the question and answer sort of in the middle of everything, but feel free, interrupt anytime needed. It's not a problem.
Okay.
So this is Fable's story. And the story of Fable Robotics system began in 2011, where the company's founders, David and Moises, were working together as robotics researchers with other engineers and designers and other researchers from the Danish Technical University, with Media Lab, MIT Media Lab, with Lego, and so to speak, a cluster of really bright robotic nerds were working around this project, which was about modular robotics. And so with time, they really observed a need for radical different educational robots. and then started looking at this transition from idea to solution, so that it sort of was smoother for both the teacher and the students to work with robots in education. So to realize such a system, the founders did this research and development of Fable in the following years. And in 2017, we shipped our first Fable robots. So it was sort of spin out of this research and innovation project that they also did with Lego, and really bright heads behind this amazing system. So looking into the future, I'm sure we'll see loads of amazing things with Fable, new launches, new releases in the software. We're not standing still at all. So I'm sure it'll be an interesting, travel or trip we're going into in the future. So why did they develop Fable? Educational institutions in every part of the world are required to adapt to new to digital technologies, because they can see that there's a transformation in life and work. So times have changed and these skills are needed. And I don't think I have to talk long about this, because you're in this webinar room with me because you know that there's a need for these changes in education. You know we have to focus on bringing in STEM and or STEAM subjects so that we can create the future workforce as being a strong future workforce with the necessary skills needed. So we know that new subjects such as programming and technology therefore have been implemented as mandatory subjects in most countries. And therefore we see there's a bigger need that schools, they also bring in these new technologies into classrooms. And we really need really good content and really good tools so that we can manage this goal of providing excellent teaching and also preparing the students for this fast changing future. So what we'll look a bit into together now, the next hour, are sort of these different learning environments that are needed, and the tool that here is Fable, of course, that we have to offer. And on sort of the background of all this is, of course, that Fable was invented as being part of this change and as being part of a belief in constructionism, where students, they use robotics as tools for learning and for enhancing, as I wrote in the third line, creativity, innovation, and making computational thinking more concrete. So we want to offer education a solution to work with these 21st century skills and to achieve knowledge in these STEM or STEAM subjects. So just to underline the constructionism, the students, they will, as you see in some of the examples, generate and develop their own thinking through working with this robot technology in several subjects and with several topics. So this is the whole exciting part of it. So what are the 21st century skills? You know these already. I just want to put them into a Fable context. Because some of they're more than just the three that I've put on the picture here. But what is important for me is to say that programming, creativity, innovation are some of the three topics in the 21st century skills that I find the most interesting to focus on. So I've chosen these as examples. And programming is one where the students, they learn the language of computers, which is really necessary when working with the new technologies that the world offers and working with robotics here. They have to get into this new learning environment of learning with mistakes and from mistakes, the trial and error concept, where coding and program is really interesting in this area because you get the instant feedback. So this is sort of the basic knowledge and skill area where programming is a necessary part, of course, of working with robotics. Creativity is the second one, where students, they sort of we've written combined existing knowledge in new exciting ways. And you can see when they build their own robots, which is what you do with Fable, it motivates and it engages the students in a really positive way, because they are themselves prototyping, creating things that nobody else has done already, or that they've taken it on existing knowledge but changed it in new ways that find value for them or for the project that they're working with. And here innovation is also part of the picture, of course, because this is where they create these projects to generate the value for specific users. Maybe we had a really great project with an 8th grader class that went into an old people's home and had to sort of look into how could they work with healthcare to create value for elderly when putting in new prototypes through robotics into their day life. Is there anything that could help them? And it was a really interesting project, which I can, dig deeper into later if we have the time and if it's necessary. But it's something that we've also put into a lesson plan that will be able to inspire you to do some of the same also. This is, of course, really important as being part of the future workforce, that they have to learn this and engage with the 21st century skills. So it's problem solving, collaborating, which are some of the skills in this too. So this is why we think Fable, of course, is perfect for education. Fable is a robot that you can build in seconds, and it's a robot where you build it. It's not a finished, ready-made robot. You saw the one next to me at the beginning of the presentation. This was a robot that I built myself. You can build loads of different robots, and it's an easy way of setting up the robot that you want to use, and then all the fun and all the creativeness is also in the programming software. So this is really the cool thing. It's not a ready-made robot for you. You put together the parts into the robot that you find necessary to build. If it's a humanoid robot or if it's a more sort of a useful technology is up to you. So also giving the students, I find, in building their own robot, you give them this amazing feeling where it motivates them a lot, and this across genders and ages and across different subjects. Also, it's designed for learning. As you work with learning the computer language, you can work with a differentiation. So you'll see that afterwards too. Then you can work with different areas of education. You can go to the younger students. You can even work them up into high school, vocational schools. You can work with schools with children with special needs. So it's designed for all these different levels that are needed in education. Also, Fable is really great because it solves real problems. And what are real problems? Real problems could be that a teenager is too lazy to pour his own Coke in a glass, or a real problem could be that we have a situation where we can't offer people water in rural areas, or we have a problem at the moment where we can't bring medicine because of the corona disease. So which kind of solutions can we find to these problems? This is what you can use Fable to do. Also, Fable grows with the user, and this is the great thing about it, that you can actually sort of work with progression. You can really sort of, it's an open-ended learning environment. You can start at one place, but you wouldn't know where to end in 5 years from now, because it really grows with what the user creates of programming and what you can build with Fable. So this is also a really important element. And what I find fascinating about it is that it's not the individual user, it's the group that works with it. So you can always, in this collaboration, see new things being created when you work as a teacher. This is there's always a wow when I'm in courses or looking into teachers' classrooms, because there's always something new popping out of these projects or the subjects that they work with. And again, it grows with the user in that way that you can use Fable in both language lessons, but also in maths, in the different science lessons. So you also find it necessary to grow with it because it has different different focus areas. So Jakob, are you still there? Everyone?
Yes, I'm still here. Can
No
you hear me?
questions?
Sorry?
No questions?
No questions? No, I haven't seen any. So I think that it's so good that people are just listening.
That's good. That's good. Okay.
Yes.
Also, just the small thing about growing with the user. I just wanted to put this small. One of my colleagues said this morning, Christian. I thought it was really wonderful. He said, "Oh, there's this teacher. He uses Fable robots in the classroom. They don't work with it as an individual or in different groups, but the teacher has used Fable as a classroom robot, as an assistant." And I said, "Oh, that's wonderful. I've heard that story before." And he said, "No, but the wonderful thing about it is that they do morning exercises." And he created a Fable Fonda, he called it, like the sweet Jane Fonda, and has then coded the robot to do a specific exercise that is shown, and then they don't have to be that close to each other, they don't have to be close to the teacher or the students, they can just look at the robot and follow the exercises that the robot does. I found that really wonderful. Fable Fonda, I'll never forget that. So this, again, we're lucky in Denmark. We have some students in schools actually at the moment up to 5th grade. So that's why it's possible for us to hear some of these positive stories at the moment. So yeah, there's a lot more to say, but I like to sort of get closer to bringing some hands-on activity into this webinar. And I won't be building these robots that you see in the picture. These are just a few of 1,000 different robots that you can create with your learners. As I said earlier, from humanoid to useful technology. You can see on the pictures that you have a bit of playful learning. You have the spin modules, which are the small ones on wheels, playing football. You have a pick and place robot. You have some with the facial expression, some without. So there are really loads of ways of creating a robot. So now I will call this showtime. So I will just sort of step out of my slideshow for a moment, and then you'll see how we can get back to the webinar and stop sharing the screen. So if you have any questions, please ask me. But now I'll just sort of give you an idea of what Fable is based on. So, the technology-wise, I'm sure many of you already know this, but just bear with us then in that way that we'll just get around everything here. I want you all to be ready to rock in the classroom with Fable. So this is just Fable I've put together as a humanoid robot. I'll put him aside and I'll just show you the individual parts in itself. When you get the Fable robot delivered, you get it in a box, and in this box you have a lid. And this lid is where I set up, I'll just put it a bit down, I'll set up my robot. So this joint module is one of the robot modules that we have. That was what you saw as the arms of the robot earlier. And this is one part. We also have the spin module, which is the other part. So these are the two parts that you can code. Also, you can code the hub that I will also show you in a minute, and you can also code the elements on the device, the phone that you use, but I will also show you that afterwards, because there are loads of great technologies in that too. So slow me down if there's anything that you want to know. But what we do is, when we open the package, is the first thing. You have your dongle, and this is the wireless connection that connects the program with the specific devices, so the joint module or the spin module. So what I'll do now is I'll put it into my computer, and then you see it turns a color, and it has different channels. So you have 6 different channels that you can choose between. Pink is my favorite one. Actually, I should go with turquoise. It matches my t-shirt. And this is really good for you to know, because if you work in different groups in the classroom, they work on these different channels. So if you have one group working with the turquoise, it won't interfere with a group working with the red channel. So this is the communication base, right? So when I've done that, I will do the same with my joint module. So on the back of the joint module, you have a small on and off button. And on the front, you have this tiny symbol, the Fable symbol, which you then have to switch into the color that is matching the one you have on your wireless connection, the dongle, or the hub, as we also call it. So this is sort of the first setting, actually. Just check, this is troubleshooting. If some students say, I can't make it work, there's nothing working, check if the colors are right. Then you're already sort of, you're going strong. So what we do is now I'll show you 3 different exercises. And this is, first of all, a simple exercise where we make the module move. The second exercise, I'll just sort of put some more progression on. So, so you'll see different ways of actually solving the same problem. Okay, so I'll share the screen with you in a second again, and then you'll see the Fable Blockly. This is where we'll be switching a bit back and forth, so that you can see the robot move, and at the same time you can see what I'm programming, so that you don't think I'm doing magic, because this isn't magic. This is coding. Okay. So I'm just opening Fable Blockly now, and I haven't sort of pre-opened anything because I want to just show you the whole, what does the whole start feeling. So if you do the same later today or tomorrow or next week, then this isn't completely new to you. Okay, here we go. So this is what's, every time there's something new in Blockly, new releases, then you'll have it on the front page here, and you can see what's what you have to be aware of. Now, this is an old code I've been working on. I'll throw it out in just 1 second. So I'll just leave the picture for you just for a moment, because this shows you the interface, and this is Fable Blockly when the students open it and when they start working with it, if they've been working with something beforehand. Otherwise, it looks like this.
Sian, there's a question here.
Yeah, bring it on.
Sheila says that, is the position of the arms important? Your Fable setup is different than the pictures.
It depends on what you, it's not important how you put them on the different modules. This is up to you. We do it actually a bit differently here when we present. So it's not necessary to do it exactly like in the pictures, no. They're magnetic.
No, maybe we should say that we have there's an X motor and a Y motor.
Yeah.
So they can go from -90 to +90.
Yeah.
So then it differs which way you have put it, of course, which way it goes. But yeah.
Exactly. So if you're building your robot and you then afterwards start coding it, then you'll be in the situation of, again, the instant feedback. If the joint module moves in the wrong direction, I'll show you that afterwards. You will be able to see where the X axis is and the Y axis, and then you can change it from there. I hope it answered your question, Sheila. Otherwise, you just give Jacob a message or a chat, and then we can go deeper into it. So this is what you see, first of all. And what I have to be aware of on the right-hand side is that the hub is the correct hub that I have. Every hub has an ID, which is in the bottom of it, so that I know that it's my hub that I'm working with. Some students do tease each other and change the colors, and then they go in and tease on taking over each other's modules. But this isn't, I'm alone here, so that won't happen. Here we have the module that I've put on now. I put on the module UVM. This is again the ID, the identification number of it. I see how much juice there's still on it, and I see how the connection is. So I'm fine, and I can actually start coding. So imagine that you have a maze that you want to start coding, that you want to solve. I'll show you the maze in a minute, and you need the movements on the joint module to work. So that's what we'll try. This is the whole Blockly setup. All the different actions that you have are on your left side. This is the advanced version that you're looking at. I will click also on the simple version, where you have less possibilities, and also in the different blocks you also have less than if you're in the advanced mode and go into actions from there. You have more you can choose between. For example, the speed is one of the things that you get extra. So this is one mode, and now I'll just choose the movement of my joint module. And as Jakob, he just said that you can go from -90 to +90 on the x-axis and on the y-axis. So what you have to be aware of is what you wanted to do. This is just a small test, which is put it on -45. And you have here an underlay of the different modules. These are the ones I've been working with, the light gray ones and active, but this one is active, and that's the choice that I have. Again, a small troubleshooting thing to be aware of. So this is the movement that I want to sort of set up. Now, I'll start playing in a minute, because I want you to see the movement of the robot, of course. But we'll just put some more things on. So when you ask the students to put together a program block by block, this is where you can sort of start. You can say, okay, we want to sort of just work with the joint module in itself. We want some movements in it. A good example is, as I said, to try to solve the maze. So when the students, they get an introduction to Fable Blockly, this is where you can start. So say the same as I did. You've got all these elements in the left-hand side. We'll start with simple mode. We'll put in some actions and some conditions and make this happen. When they then have several projects, they can save them, they can open the older ones that they've had, and they can even open some examples that we've created on forehand. So here you have some different examples for join modules and some for spin modules that you can use. Sometimes it's good to give them some ready-mades on forehand, or you can ask them to analyze, or you can even sort of ask them to change some things in it so that it doesn't seem like such a difficult task to go through. Also in the small wheel here, you can change the language if needed. What is also important, not to sort of dig too deep into all these elements, is that you have your whole getting started guide right next to you. So if there's anything that you aren't aware of, just go through the checklist here. It's very easy accessible for you. So this is anyway an icon that has quite huge importance when you're new in using Fable. So now we wanted it to move a bit. We want to create some action. So what we can do is we will put in a condition. If true, then do this. But as I said before, we want a bit more movement. And when you create a program like this, now I just talk over it here. When we want to create a program like this, it's really important for you to tell the students also that the program reads everything from top to bottom. So we have to put in these small waiting blocks so that it knows that it has to wait before it goes to the next pass. I'll duplicate this. I just did it with Control C. You can also click on the right hand side and then duplicate. So I'd like it to move back to the center where it was. And yeah, this is just my finished little small program. But I wanted to say something to you too. This is the computer speaking. Hi, my name is Fable. I'm a language teacher. I don't like mistakes. I just put in a big F. So this is then where you press the play button and stop it again. So I'll just put around the loop so that we can make this happen. And again, you can sort of say, okay, I want to put in a condition so that I can be the one in charge of this. And there's several conditions or several senses that you can choose between. And I would like to use this one if I press the space bar. I'll just open this up again actually in the advanced mode, because what is really interesting here is, of course, that you have so many different options that you can choose between. And again, here is where creativity is part of it. And again, just trying to work with the trial and error or trial and error of programming, which is really important. So now I'll just play this for you. I'll stop sharing a second and we'll be back. Just testing, I have the colors right. I'll just open Blockly. I'll press the play button and nothing happens because I have to press.
Hi, my name is Fable.
The space bar.
Hi, my name is Fable. Hi, my name is Fable.
So this is sort of the simple way of, you can continue creating small elements on this one. And what I said earlier was that I wanted to solve this maze. This is a good starting exercise for the students. We have these elements that you can, these modules that you can click on, your different Fable modules. And on this, you can maybe recognize the Lego design. You can put Lego bricks on it, but you can also design your own parts. So you can 3D print loads of different parts that you can connect. And we have sort of, this is, these are all the small connections that you put in. You just click it in, and then it's ready for you to use. So if you are in a makerspace and you have a 3D printer, it's a really great idea to also bring in the creativity of asking the students to also create their own parts for the robot. We've seen students creating hands because they thought it was weird that Fable doesn't have a hand, so let's create a 3D printed hand, or a spoon for the elderly, again, that I talked about earlier at the home, the nursery home. So you can create loads of interesting 3D prints yourself. So this way of solving this one is, like I just showed you, block by block and bit by bit, that you solve a whole maze. This takes time, but it's again something where you work with students about what elements are important when you work with programming. So just learning the whole idea of it. And then they can put in sounds, they can put in different senses and so on. So this is just a very simple version of something we can do. But the next sort of, if you want to sort of create a next level of this, I will show you how to work with follow the leader. And follow the leader I've seen is a really interesting part when working with problem-solving projects, because it can solve loads of different things. So I'll just show you how I would work with it and in which kind of projects over which topics I would do so. So we could say this is the same thing we want to solve. So let's start just teaching the students how to program it with follow the leader. And then we'd like to sort of make the students recognize where would this be a valuable robot when thinking worldwide topics, other subjects. So if I just go into Fable Blockly again. I will share the screen with you. I forgot that. I'm sorry. And what I did here was I went up to the folder again. We've cheated a bit here. We want to open an example like I showed you earlier, and we can actually just pinch from here, follow the leader. So this is just a bit big. I just want to pull it over to the side so that you can see it. So one thing I didn't say earlier, which was now sort of working with progression, you've had the simple mode and you've had the advanced mode. But what you can also do is you can work with integrating Python. If you want to do it in a slower mode, you can integrate it by, when building this, the program, putting together the coding blocks, you can see the change over in the right-hand side where you have the Python coding elements. So if I do a change here, it'll also change in that area. So if I delete something, it'll also be deleted in the Python block. I'll just do a Control-Z and change that again. So this is a way sort of beginning to let the students have an awareness of things going on in the Python code and what happens if I change anything here, which kind of language do you see in the written language in Python instead? And the next step would then be to say, okay, the icon that you see in the top, you can do the full switch over to Python and the students can work with this. We do have example of lesson plans where you work with Python in different levels. So you could start there also. When you do changes in here in Python, in this part of the system, then it won't be brought over into Blockly. So if you do changes here, this is where you'll stay. But the other way around, if you do changes in Blockly, you'll see it in Python. So just do this a bit smaller so that you can see the whole. This is actually, there's a small variable that is put on this code, a variable that isn't really necessary, but as soon as you put this on, it's easier for you to do the changes in the modules every time you open it. So you can do a simpler version of follow the leader where you just remove the variables. It's not such a big issue. So what I'll do now is now you can't see it, but I'm taking a new joint module. And of course, I need the color turquoise. I should have put in a competition here. You should have chatted which color to choose, but I was a bit quicker. And now you see that two modules have been found. So I still have the UVM that I had earlier. Now I have the BCF2. So what I do is the one that I have on my lid, I would like to use as the follower. So I have to identify this as the UVM, and the other one is then the leader. And there you see I don't have to go in and change anything in the code here. So as soon as I press play, this is what will happen. Now I will stop sharing. So what we saw before was we made the maze work by, or we didn't, you didn't see it actually, but by putting together block bit by bit. Now what I do is I use this as my leader. So as soon as I start using this, the follower will follow me. And here again, I don't know who asked, if it was Sheila, again, sort of what Jakob was talking about, the y-axis and the x-axis. In a minute, when you see me moving this, you'll see if I will move them in the same direction. So I have to be aware of the y-axis and the x-axis. If it's important for me that they're set in the specific, in the right directions here, in the same direction, there's a tiny little symbol of a minus and a plus. This is just a small detail, but a really important detail to help the students just prepare themselves a bit better. So we'll see how this works. I'll just check if they're in the right, in the same position. So they are now. So what I'll do is I will press the play button. And as soon as I move my leader, the follower will follow me, okay? And this is quite an amazing code because you can imagine that you have maybe solar cells instead of a maze, sort of any bigger. This is again where what I said earlier, get the students to be involved in this process. Where is this important? I was a former arts teacher. I thought about Andy Warhol as one of the examples, first of all, but on the other hand, sort of having the possibility of having hundreds of these next to each other, 100 followers and one leader, and I could make it paint loads of beautiful paintings. So it could also be used as in a more playful way, for example, or it could be used as sort of real problem solving some real issues. As I said earlier, you want somebody to bring water out and you're not able to move into the room, maybe again by the elderly, but you can bring them the medicine or water by steering the module that we have here. So I'll just try and switch this over and see, is this maybe something that we could use too? So what I'll do now is I'll show you the code again. I'll share the screen, and then let's try and see if we can use follow the leader with our spin module too. Because this is where we can do amazing stuff. So here we have, I'll just stop the code so that it won't. So, and what we then do is we want a different action. We want the action to be the spin action instead. So we take that, and then of course, if we want this to be in the most simple way, we can put in the exact same elements from the joined module and ask the spin to do this. Sorry, it wasn't meant to get stuck there. You can hear them click. So what we need is the BCF still being the leader. We have to put on the spin so that we get the correct color and connection. The connection. Did you want to say something, Jakob?
Yeah, there's a question here about how far apart can the follow and the leader be? Well, if I should answer, it depends on how many other wireless things you have connected. But I have tried for as long as 10 meters. But yeah, it varies if you are in a place where there's a lot of mobile phones at the same spot, or you are at an event or something. Then it could, of course, be different. But yeah.
Yeah. It depends.
I have some questions that I have written down.
Yeah.
So just whenever you feel for it. We have a question regarding there's Jackie that wants to do some home learning for her students.
Yeah.
If we could show that at some point.
I'll get back to that. That was the small surprise. I said I'd give.
Oh yeah, great. And there's also another one that wants to know about our lesson plans. So I think we could take that at the same spot. And then there's a question about AI.
Yeah.
And well, we can maybe tell a little bit about AI in a simple way, and then we could get back if because you can also do pretty advanced things, but that will be, I think we won't have time to do that here, but we can send that in an email or something.
Yeah, and I can see time is actually running, so
yeah, exactly.
We'll get all these things. I think I'll just show you this teeny weeny thing, which is the third sort of progression path. And then we'll get into the lesson plans and some of the activities, okay? Because this is where you can sort of follow up yourself a bit more and you don't sort of need my full support. And we'll take the questions from there. So this was the spin module. I won't give you sort of all sorts of huge details around it, but we have different sensors where you can work with loads of really interesting things, including sensors. There's sensors regarding distance, color. There so many different ways you can work with this part. This is also just an engine, as one could say, that I've put wheels on. Okay, I've just clicked them on. So we want this one to move as part of this code, and see the movement of it as soon as it's going backwards as soon as I use my joint module. So one thing that we had a competition here where we had a football field, and we wanted to, I just stop the program so it doesn't run, where we wanted to use this module, the spin module, to play football. So where we had this on and it pushed the ball around the football field, which you can buy on our homepage, by the way. This is really part of playful learning, both for children and for grown-ups. And I found it quite difficult. I was playing against some of our software developers. So I created the code instead where I do block by block, and I used the condition where I chose, like when you computer game, I chose the W to move forward, the A to move left, the D to move right, and then it moved as I wanted it to, and I could steer it in a lot better way. Some of the other wise engineers we have just sitting next door here, they use the joint module and follow the leader. You can also use the Fable face, and this is where this technology is really, really important. Do include it as more than just the humanoid robot part, because it has all the sensors that you can use. You can use it as the accelerometer, you can use it as the tap functions, so that if you do specific things on this app, you can make the robot move. So again, you can sort of put together Fable in all sorts of different ways, where you say, okay, we'll take apart this one, and we want to move this, but we'll do it through the technology that the phone has, instead of the technology that that we can find in only the program. So it's just to show you that this simple building and taking things apart is really an easy way of getting all sorts of things done. This isn't a maze that we want to solve, but this might be maybe a more problem-solving project. So if we can press play, I can make the robot move with the axes that I use. So one axe is the engine that you have here, and the other axe is the engine that I have there. So there's so many amazing ways that you can. I'll just stop it here so that we can get a break, where you can use either sort of follow the leader blocks or simple blocks that you build yourself, or using the phone. If I manage the phone one, I'll do that at the end. But first of all, I think we should just show you some of the activities and some of the lesson plans we have. Yep. So I'll just go back to the slide, share the screen with you from there, and then I will show you some of the elements. I have the links in there, that's why I want to share this with you. So these were just sort of tiny, you got a tiny view into what Fable Blockly can do. And as you see here, a picture sometimes says more than 1,000 words. You can use it as something where you work with technology. You can use Fable as color sorting, where you use the sensors that I talked about. You can work with storytelling, where you create these future pets, maybe for the younger classes. There's so many different options that you have. As you see in the right corner, we also have the Sustainable Development Goals, which are really in and hot at the moment. There are many projects, many lesson plans where you can work with that too. So there are many ways of going, many subjects you can cover, and many ages that you can cover. So I've put together, and as I said at the beginning, you'll get these slides too, so you can sort of look into this yourself too. But there's this huge range of projects. I'll just click you into the link here. We have our lesson plans partly on Workbench, but also on our homepage. We're putting most of them over to Workbench. They're not all there yet. But what is important for you to know about this is that you can actually either just pick out the lesson as it is here, but you can also change it and put it into an order that you find valuable for your students. You can put more elements into it or pick some of the things out, so you can make it your own.
Yes, you just have to have an account on Workbench, so
yes.
then you can make a copy. That's right. Yeah.
Exactly. And then from there on, you can work and plan it as you want to. So this is one project, Humans and Robots, which would really also be interesting, talking more ethical for the older students. Then there's a topic like health technology, which was again the topic that I talked to you about earlier. And everything we have here, all the documents are there, they're planned for you. There are all sorts of inspirational links also. And we also have this covered under the UK curriculum. So if that's necessary for you, there's also a possibility to do that. Okay. And
yeah.
Industrial topics is also a completely different way of grasping robotics, but also really necessary. Drawing with a laser is one way of working with Fable also, so that they get an idea of what this is like. This is construction. This is also maybe a very important topic for some vocational schools. Where you can work with more sort of industrial topics. This was just one simple example. And the novel engineering, again, language learning, cultural aspects. This is Charlie at the Chocolate Factory. If we want to use Fable in other contexts, then you can also use it in language learning and, again, the cross-cultural aspects. It's really interesting. We worked with it also with refugee camps, where you can actually have them tell their story through Fable. So there's some really good examples of that. And then again, the Sustainable Development Goals, really important issues that we have in the world at the moment. Get the students, be part of it, take part of it, create prototypes, and get the feeling of helping actual problems being solved. This is really, really an interesting topic. The plastic production especially is one of my favorites. So dig into this. There are loads of different lesson plans that you can look into. And one of you asked about the activities. Could you do something if you're not in the classroom? We've created this page. You can find it on our homepage under teaching material. And under this teaching material, you find all the lesson plans where I just showed you some examples. They link you directly into Workbench. You have different activities, again, that you can sort of build your progression of different small activities. Or if you want to work with sort of more station-wise in classrooms, then you can do that too and create activities from here. And there's loads of video inspiration, both here, but also on our YouTube channel. So here are the activities without a robot app. And what I find really nice about them is that the students actually get to know some of the basic elements that you have to know when coding. What is important when you have to code somebody to do something? With Fable, it's the robot, but what if you should code your parents to bake a cake? Or what if you should do code a morning exercise? This Fitness Unplugged is really fun. So this is sort of both part of getting the basic skills. They will also work in Fable Blockly, which you can work with at home, just without the robot. You can also give them some exercises which are more about the process in it, sort of the whole process, design thinking process that the students have to be in. And there are loads of sort of exercises where they also have to sort of think a bit differently than they do normally, get some quirky ideas and some strange ideas to create something new. So please look into these. They're really fun. And again, also some more difficult than others. You see the Python parts here. Yeah, Jakob, I can see I have 6 minutes left.
Yes. So the question about AI.
Yeah.
Yeah, we would like to get back to that. But you also want to use some time on the progression there.
Yeah, just shortly. This is just a good slide that shows you a progression, which is this is the same module that you use with different steps of education. I'll just leave it for you to read at some other point, but this is one joint module that I showed you that you can use in so many different levels. So it's just an important part. And again, Human Brain Project, AI, as you said, Jakob, this might sort of fit here. That we are working on some developing some new releases on Fable also, which are more into AI. So the future will hopefully bring us there.
But if I can just say that AI, what is it? That could be a lot of different things. It could be on a very low level. It could be just for example that you can have the sensors. For example, there's a program if you open in Fable Blockly, there's a where you can have the Fable spin drive towards the light or away from the light. That could be an example of a simple way of artificial intelligence. But as we explained in the beginning, David, our boss, was used to be a researcher in artificial intelligence. So maybe if you have specific questions about artificial intelligence and how you can do it on a higher level in Python and that sort of stuff, then we could write us an email. We will get back to you on it.
Yeah, that's a good idea. And I'm sure we'll see some great stuff in that area in the future. I'm sure. Okay, good. I hope, that answered the question. So shortly, this is just if you have specific bundles or any questions regarding what you should purchase if you don't already have Fable. The Fable Makerspace Plus is great if you have the class environment. And again, it's easy to pack, it's easy to unpack. You can bring it from one class to the other, and several teachers can work with it at the same time. If you just want to get started and get hands on it yourself, feel free to connect with us, get a trial version, get a Fable Go or a Fable Explore, and get to know Fable in a really easy way. But you can find all the information on our homepage, or you can talk to any of our global partners that we work closely with, and thanks to them, we can reach out to many of you in the world. Or you just connect with Christian, he'll help you in any way, and I will myself too. So as Jakob said, you can always connect with us, and we'll be happy to answer any questions that you need answered. So if there's any sort of a question at the end of this, do you have anything that we should mention before finishing it up?
I think we are more or less there. I think I have tried to get around all the questions.
All the questions. Good. And if anybody feels left out, find my mail on our homepage and write to me directly, or through the information flow that you get from us. And also keep an eye, because I think one of the next webinars I'll be having will be for children with special needs, which is also a sort of a more didactical discussion that we will be taking in how we can use Fable there. It won't be so much hands-on, but we'll show you some really good exercises and some structures that you can look into in how you can plan your lessons from there on. I think it's also just as interesting if you don't have children with special needs, but it will be the focus. So keep an eye, and thank you very much for staying with us.
Thank you very much.
And I hope we'll stay online just a few more minutes. If anybody has a question at the bottom, we can just reply through the chat. So Take care, everybody, and please stay healthy. And hopefully, everything will be more positive in the future. In the near
There's just
future.
a question here from Angela on the private chat. Do you have the spin module to work with the wheels, or will the wheels work with the classroom sets? Yeah, you can. Yeah.
Yeah. The spin module. I don't know if I understand the question right, Angela, but the spin module works with the wheels. I'm not quite sure.
No.
But Angela, maybe.
I think it's because that you didn't. Oh, you did show the spin.
I did show the spin module.
Oh, it's because you didn't show it on the wheels with the wheels on it, maybe.
No, it was shortly anyway.
Yeah.
It drove out of the picture.
That's an important thing that you have. If you use the spin on with the wheels on, you have to remember, especially with the pupils, to tell them to put it on the floor before they actually activate their code. Yes. Otherwise, it will drive off the floor.
And also, a tiny detail that you usually mention, Jakob, that I always forget is that you have to. These two engines work in each direction. So you have to, in the code, have -50 and +50 on the two different lines.
Exactly.
Okie dokie. I think we'll finish up here. If there's anything else, please connect with us. And thank you very much again for joining us. Take care. Bye.
Bye-bye.